Now it's time to build an Ethernet switch. An Ethernet switch is definitely more complicated than a hub or an ARP cache, because the Ethernet switch has to do an actual lookup before it makes forwarding. So in an Ethernet switch, we have a table with destination MAC addresses and which ports they belong to. And whenever an Ethernet frame is received on a port, then this MAC address table is consulted and a lookup for the destination MAC address is made before the frame is finally transmitted out of that port. When the Ethernet switch boots up, it doesn't have any idea about these MAC addresses or where they belong, because switches depend on learning from the data plane. So that also means that when an Ethernet frame comes in with a source MAC address on port 7, for instance, then that specific MAC address is recorded in the MAC table along with the port that it came in through. So in that way, the Ethernet switch is populating its own MAC address table based on the incoming frames, where it creates records that correlates source MAC addresses with destination ports, and then uses that information going forward. So as we build this forwarding logic, we will be learning about functions, nested dictionaries, doing calculations with numbers, and string slicing. So let's dive in. So the entire forwarding logic is built up around that MAC address table. I think it would be a good case for a dictionary, since we have a key and the value. The key would be the MAC address and the value would be the port name. As the switch is booting up, it has no idea about which MAC addresses belong to which ports. This will be populated dynamically as the switch is forwarding traffic. Because whenever a frame is coming into an interface, then the source MAC address is read and recorded inside of the MAC table, which enables the switch to forward traffic to that specific port later on. So the most fundamental properties of an incoming frame would be the source MAC address, the destination MAC address, and the ingress port. So let's just announce that on a debugging message here, that we have received an Ethernet frame on this ingress port. From a certain source MAC address to a certain destination MAC address. So I'll run that. The first thing my switch will do is to record which port the source MAC address was seen on. And then let's just print out that MAC table to verify. So we have a dictionary with one entry inside of it, where the MAC address is the key and the switch port name is the value. I could then repeat the process here for multiple incoming frames. So let me just copy my code and swap around these two MAC addresses, since they are probably communicating with each other. One is on port 1, the other is on port 2. And let's run the script again. And we now see these two incoming frames from two different source MAC addresses on two different ports, and that populated the MAC address table with two different entries. But I'm repeating myself right here inside of my code. So whenever you see that happen in your code, you should think about defining a function instead. So a function is a reusable code block that we can invoke multiple times with different parameters. So let's define it up here using the def keyword. So I'm receiving an incoming frame. And I have some important data that is related to this frame, so I'll define that as parameters for my function. The function is a code block, so I'm ending this with a colon and adding some indentation. Then I'll simply just copy my code up there. And then I'll just invoke the incoming frame function with these different values as the parameters. So I'll put in the source MAC address, the destination MAC address, and the ingress port up here. I don't even need these variables anymore. All right, let's just try to execute that. We can see that the result is exactly the same as before, but my code is a lot more readable now because I'm reusing my code block and not repeating myself. So this function will always be called with 3 individual parameters, and these parameters that are sent along with it will be mapped to the variable names that I define up here. And they are positional, so that means that when I call the function from down here, then the first value will be mapped into source MAC, the second value will be mapped into destination MAC, and the third value will be mapped into ingress port. We can also reference the parameters by their name as well, to make it a bit more obvious to the reader of the code what is going on. So if I'm far down my script a couple of 100 lines later, then maybe I won't remember the precision of these different parameters. Then it's much easier just to define them with their names. It does require a bit more code, but it's also easier to maintain because it's completely obvious that source MAC address is assigned this value. So if I'm saving this, running it again, the result is still exactly the same. I have prepared a lot of incoming frames. So I'll just paste them in here. And I'll run my script again. And now I see all of these announcements of received frames on various ports, and then the MAC address table gets more and more populated. I think we should print out this MAC address table in a way that's a bit easier to read. Let's use the format that a Cisco switch has when you do a show MAC address table. So I would like to define that as another function. This function doesn't take any parameters, but I still need the parentheses here. I'll just keep them empty. So at the top of the output, when you do a show MAC address table, you have a header that looks like this. So let's just start by printing out that banner at the top. Now the next thing I want to do is to iterate through all the entries in the MAC address table and then print one entry on each line below these column headers. And you know how to loop over a dictionary because we did that with the ARP cache. We have 2 different variables that we need to populate, the key and the value. The key is our MAC address and the value is our interface name. So I'll assign them to the items inside of the MAC address table and create a new code block for that, because then below this, I simply want to print out the MAC address and the interface name. So this is the function. I'm defining it at the top of my script file, and then I'm using it later on. So instead of just printing the MAC table dictionary right here, I want to invoke the show MAC address table function without any parameters. And then the output will look like this. So let me just fix the alignment here to make everything look nice. Let's try again. So this looks quite similar to what you would see on a Cisco switch. Actually, a switch will usually sort the MAC addresses alphabetically. So let's just do that to make it more realistic here. That's quite easy with Python. You can simply add sorted to the items of a dictionary. We'll call that function, and I'll rerun my script. and we can see that they are now sorted alphabetically down here. So that's a bit more user-friendly. So with that out of the way, let's try to implement the forwarding logic. Because right now I'm only populating the MAC address table. I'm not forwarding anything. So it's not enough just to populate the MAC address table. We also want to implement the actual forwarding logic. That's why the Ethernet switch is there to begin with. We need to forward frames. So in the ideal situation, the destination MAC address will be present in the MAC table. Let's just verify that first. So that's quite easy in Python. When you have a value, you want to check if it is present in a dictionary or in a list. You can use the in keyword. So if the destination MAC address is in the MAC table, then I'd like to forward the frame. And this is a function that I'm defining. So let's just do that first. Forward frame. So logically, I would need the destination MAC address and the egress port to actually go ahead and forward the frame. I'll emulate my forwarding simply by printing out this message. So anywhere that I'm calling this forward frame function, I need to supply a destination MAC address and an egress port. The destination MAC address is easy, because we have that in the incoming frame. But the egress port, I need to look that up in the MAC table. Since I know that the destination MAC address is there, I can simply just access the value like this. So let's see what happens now. Oh yeah, I forgot to actually add that egress port here. And I get an error from my function here that it's missing one positional argument. So let's just add that in there. And try again. All right, so now we can see some transactions going on here. Let me just slide this one over so we better can see it. So we get a lot of received frames, and some of them, the switch is able to forward. It's only able to forward the frames that are present in its MAC address table. So for instance here, it has a broadcast destination, and the next one has a MAC address that starts with 99, 88, 77. We haven't heard about that address anywhere before this, so it's currently not in the MAC address table. And remember that every time I run this script, it begins from scratch with an empty MAC address table. So I need to figure out what should happen when a frame is received with a destination that is unknown. That could be either an unknown unicast MAC address or broadcast. So let's expand the forwarding logic with two additional conditions. So in if statements, if we have only two different conditions, which is either true or false, then we just need if and else. If I have more outcomes than that, then I would need the if statement as well. So I can have many of those, and they behave just like an access list. They are processed from the top and down, and as soon as there's just one match, then that's the code block that will be executed. So to make it clear what's going on here, I'll just add some debugging messages to my code. All right, so this is the case of a well-known unicast address. In case of broadcast, I'll just print destination is broadcast. And then I would like to flood the frame. I'll define that function in a moment, because I just need to put in my last case down here that if everything else fails, then I also want to flood the frame. That's the behavior of a layer 2 Ethernet switch, that if an incoming frame here on port 7 has a destination address so 99, 88, 77, that is not known, then it should just be forwarded out of all other ports. Not the port that it was received on, but any other port. So unknown unicast and broadcast will be handled in the same way. It'll just be flooded. So let's implement that flood frame function. So to flood a frame, I still need the destination MAC address. But I don't need the egress port, because this should be forwarded out of many different ports. But I do need the ingress port though, because that's the single switch port where I'm not forwarding this frame out of. So the parameter here is slightly different. So let's just print a message here. Flooding to all other ports. And then I think it would be appropriate to make a Python loop to loop around all the possible ports. We haven't defined those yet. So let me just do that up here at the top of my script. So I'll just create a list of Ethernet ports. All right, I have an 8-port switch, so 8 items in my list. Now I can then do my for loop for egress port in interface names. It's the same logic now that we had with the Ethernet hub. That in all the cases where the egress port is different from the ingress port, we should forward it. So I can check for that by using a negative comparison. So this exclamation mark means not. So when the egress port is not the same as the ingress port, then I can go ahead and forward the frame. So now you see that it becomes even more useful that I'm defining this forward frame as a function that I can reuse, because this will now be referenced from multiple different places in the code. So let's save it and run the script. So I was missing the parameters here. So right now I'm missing the parameters when I'm invoking the function. I have 2 positional parameters, so I need to supply them when I'm invoking the function as well. In both cases down here. So I'll save that, run it again, and now we see a different picture. So let's just go to the top here. So the first thing that happens is that a frame comes in from an unknown MAC address, which will then be added to the MAC address table, and also to an unknown MAC address. And this is discovered by our forwarding logic here, that it was not found in the MAC address table, so it's flooding it to all other ports. So it was received on Ethernet 0/1, and then it's forwarded out of 0/2 through 8. The next frame that it receives has a different source MAC address, so that is added to the MAC address table, but the destination MAC address 001122334455 was already known. So that one is just unicast forwarded out of the corresponding port. So that is how it goes for all the well-known MAC addresses. Once in a while we also see some broadcast right here, and this will also be forwarded to all other ports. So it was received on Ethernet 0/2 and forwarded on 0/1, 0/3, up until 0/8. As the switch is processing this layer 2 traffic, then we would see less and less flooding. And in the end, it would only be broadcasts that would actually get flooded, and all the other frames would be unicast forwarded out of the specific ports where they belong. And in the end, we can see that the MAC address table was populated like this. And whenever it's populated, then the switch is able to do very effective forwarding. So as you can see right now, the code quickly becomes more complicated than what we've worked with up until now. The good thing about functions is that as soon as you have defined them and implemented the logic inside of them, you can just collapse them like this in your code editor. Then you don't need to worry about all of the implementation details inside of them, because you will simply just be invoking those functions and reusing the code that you have already tested. So when we have collapsed our functions here, then it all becomes easier to manage. So I think we're done with functions for now.